Welcome to the podcast, Koala Reading AI. I am your host and the voice behind the text-to-speech model. Get ready for an exciting journey through the world of computer vision. In today's episode, we have fascinating papers to discuss. Let's begin with a brief overview of each one. Paper 1. WavJourney Compositional Audio Creation with Large Language Models. The paper presents WavJourney, a system that generates audio descriptions for images, achieving state-of-the-art performance on the AudioCaps benchmark. Paper 2. LoraHub Efficient Cross-Task Generalization via Dynamic LoRA Composition. The paper discusses a method for enhancing the efficiency and modularity of LoRA modules. Paper 3. Points to 3D. Bridging the gap between sparse points and shape-controllable text-to-3D generation. The paper presents Points to 3D, a text-to-3D generation framework that bridges the gap between sparse 3D points and more realistic and shape-controllable 3D generation, achieving significant improvements in view consistency and prompt relevance compared to prior works. Paper 4. Adaptive Frequency Filters as Efficient Global Token Mixers. The paper proposes a lightweight network design called AFNet that uses an adaptive token mixer to preserve spatial structure information during token mixing, achieving superior results in object detection and semantic segmentation tasks. Now that we have an overview of these exciting papers, let's take a deep dive into each one. We'll explore the abstract, methodology, and key results of each paper. Paper 1. WavJourney Compositional Audio Creation. Abstract. The paper titled WavJourney Compositional Audio Creation with Large Language Models explores the potential of large language models, LLMs, in creating intelligent audio content. While LLMs have been used extensively in language and vision tasks, their potential in audio content creation remains unexplored. The paper presents a novel approach to creating audio content with storylines encompassing speech, music, and sound effects, guided by text instructions. The authors demonstrate the effectiveness of their approach through real-world case studies. Method. The paper proposes a method for creating audio content using large language models. The method involves generating an audio script from text instructions using a pre-trained LLM. The LLM is fine-tuned on a dataset of audio scripts to improve its performance in generating audio content. The generated audio script is then converted into an audio clip using a text-to-speech system and a music and sound effects library. The authors also propose a novel approach to evaluating the quality of the generated audio content using a combination of objective and subjective measures. Results. The paper presents the results of real-world case studies to demonstrate the effectiveness of the proposed method. In the first case study, the authors generate a radio drama for a love comedy scenario. The generated audio script effectively captures the storyline and the emotions of the characters, and the resulting audio clip is of high quality. In the second case study, the authors generate a 1-minute introduction to quantum mechanics by a professor. The generated audio script effectively conveys the key concepts of quantum mechanics, and the resulting audio clip is of high quality. The paper's approach is innovative in that it combines the power of large language models with a text-to-speech system and a music and sound effects library to create intelligent audio content. The proposed method has the potential to revolutionize the field of audio content creation by enabling the creation of high-quality audio content with minimal human intervention. Paper 2. LoraHub Efficient Cross-Task Generalization via Dynamic LoRA Composition. Abstract. The paper presents a new method for natural language processing called LoraHub, which aims to improve the efficiency and performance of language models. The method utilizes LoRA modules, which are designed to be modular and composable, allowing for greater flexibility in model architecture. The authors compare the performance of LoraHub to both zero-shot learning and in-context learning in few-shot scenarios, and find that LoraHub outperforms zero-shot learning and closely resembles the performance of in-context learning while using fewer tokens. The authors also analyze the attributes of LoraHub and compare it to other methods such as LoRA tuning and conventional fine-tuning. Method. The LoraHub method is based on the use of LoRA modules, which are designed to be modular and composable. LoRA modules are composed of a set of layers that can be combined in different ways to create different model architectures. The authors use FLAN T5 large as the base model for their experiments and add LoRA modules to the model to create LoraHub. The authors also use a variety of datasets to test the performance of LoraHub, including the glue benchmark and the superglue benchmark. Results. The experimental results show that LoraHub outperforms zero-shot learning and closely resembles the performance of in-context learning in few-shot scenarios. The authors also find that LoraHub uses fewer tokens than in-context learning, making it more efficient. The authors analyze the attributes of LoraHub and find that it is more modular and composable than other methods such as LoRA tuning and conventional fine-tuning. The authors provide examples of use cases for LoraHub, such as question answering and sentiment analysis, and show that it outperforms other methods in these tasks. Overall, the paper presents a new method for natural language processing that improves efficiency and performance while being more modular and composable than other methods. Paper 3 points to 3D, bridging the gap between sparse points and shape-controllable text to 3D generation. Abstract, the paper points to 3D, bridging the gap between sparse points and shape-controllable text to 3D generation proposes a new framework for text to 3D generation that leverages both 2D and 3D diffusion models to generate more realistic and controllable 3D models. The proposed framework, called Points to 3D, introduces controllable, sparse 3D points to guide the text to 3D generation process. The paper demonstrates the superiority of points to 3D in generating view-consistent and shape-controllable 3D contents through qualitative and quantitative comparisons. Method. The proposed points to 3D framework is designed to address the limitations of existing text-to-3D generation methods that rely solely on score distillation to supervise the generation of 3D models. Score distillation is prone to suffer from the view inconsistency problem, and implicit NERF modeling can also lead to an arbitrary shape, thus leading to less realistic and uncontrollable 3D generation. Points to 3D leverages both 2D and 3D diffusion models to generate more realistic and controllable 3D models. The core idea of Points to 3D is to introduce controllable sparse 3D points to guide the text to 3D generation process. The framework performs score distillation to the 2D image diffusion model, ControlNet, to distill knowledge from both 2D and 3D diffusion models. Results? The paper demonstrates the superiority of Points to 3D in generating view-consistent and shape-controllable 3D contents through qualitative and quantitative comparisons. The proposed framework outperforms existing methods in generating more realistic and controllable 3D models. The paper also provides examples of use cases for Points to 3D, including gaming, virtual or augmented reality, and robotic applications. The framework's ability to generate more realistic and controllable 3D models can potentially revolutionize these industries by enabling more immersive and interactive experiences. Overall, the Points to 3D framework represents a significant advancement in the field of text-to-3D generation and has the potential to impact a wide range of applications. Paper 4, Adaptive Frequency Filters as Efficient Global Token Mixers. Abstract. The paper proposes a new lightweight network design called AFNet that is capable of precisely localizing and classifying objects in dense prediction tasks with diverse object scales and complex backgrounds. The proposed AFNet achieves this by introducing a new token mixing method called Adaptive Feature Fusion, AFF, that preserves the spatial structure information during token mixing. The AFF method is mathematically equivalent to adopting a large-size dynamic convolution kernel as the weights for token mixing. The paper presents qualitative results of AFNet on object detection and semantic segmentation tasks, demonstrating its effectiveness in preserving spatial structure information and achieving superior running speed compared to other methods. Method. The proposed AFNet architecture consists of a backbone network and an AFF token mixer. The backbone network is responsible for feature extraction, while the AFF token mixer is responsible for preserving spatial structure information during token mixing. The AFF token mixer is composed of two main components, the Adaptive Feature Fusion module and the Adaptive Token Mixing module. The Adaptive Feature Fusion module is responsible for fusing features from different levels of the backbone network, while the Adaptive Token Mixing module is responsible for mixing tokens from different feature maps. The AFF token mixer is designed to be lightweight and efficient, making it suitable for real-time applications. Results. The paper presents qualitative results of AFNet on object detection and semantic segmentation tasks. The results demonstrate that AFFNet is capable of precisely localizing and classifying objects in dense prediction tasks with diverse object scales and complex backgrounds. The paper compares the performance of AFFNet with other state-of-the-art methods and shows that AFNet achieves superior running speed while maintaining high accuracy. The paper also presents visualization results that demonstrate the effectiveness of the proposed AFF token mixer in preserving spatial structure information during token mixing. The paper concludes by pointing out the limitations of the proposed method and suggesting future research directions. Overall, the proposed AFFNet architecture and the AFF token mixer represent a significant innovation in the field of computer vision and have the potential to be applied in various real-world applications such as autonomous driving, robotics, and surveillance systems. Thank you for listening to Koala Reading AI. Hope you had fun.